Hello class, today's tutorial is on bond enthalpy. We can use the enthalpy of a bond, the energy released from a bond when it's broken, to calculate the total enthalpy of a reaction. By definition, average bond enthalpy is the energy that's required to break 1 mole of bonds in the gaseous form of a covalent molecule. And it is an average bond enthalpy because these bond enthalpies are averaged over a wide variety of compounds that contain that particular bond whose enthalpy we're calculating. So for example, we could calculate the energy released when I break a carbon-carbon bond in propane, or I could calculate the energy released in a carbon-carbon bond found in hexane. Well, because their environments are different, propane having only 3 carbons and hexane having 6, the amount of energy that's released might be slightly different. So I'm going to take the average of the energy that's released when the bonds are broken in different types of compounds. So that's where I get the definition average bond enthalpy. Now there are some assumptions around this idea of the average bond enthalpy, and one of them is that there are no intermolecular forces. Well, most of these carbon substances are not going to be in the gas state. So we know that there will be intermolecular forces in those compounds that are liquids and solids. And that will affect the amount of energy that's released. Because not only do I have to break the bond, but I also have to break the intermolecular force. And then, like we mentioned, the environment of a carbon-carbon bond is different across different carbon-carbon containing compounds. So what steps do I follow to use bond enthalpy to calculate the enthalpy of a reaction? So here's the formula. I'm going to sum the enthalpies of all the bonds that are broken in the reactants, and I'm going to subtract them from the sum of the enthalpies of all the bonds that are formed in the products. And that will give me an overall enthalpy of the reaction, and that makes sense. So the way we're going to solve these problems is first I need to draw the structural formula. So you'll be using your talent at drawing Lewis structures to remember how to draw the shapes of these compounds so we can see where the bonds are and between which atoms they are. After I've done that, I'm going to count the number of bonds broken in the reactants and the number of bonds formed in the products. Then I'm going to multiply these numbers that I've counted by the actual bond enthalpies, which I can find in my data booklet on page 11. And I'm also going to have to include any coefficients from the balanced chemical equation. So let's do a sample problem together. So in this reaction, I see the hydrocarbon ethene is reacting with hydrogen bromide to form bromoethane. So let's draw the structural formulas. So I have 2 carbons that are bonded to each other, and then I have my 4 hydrogens attached to those carbons. And then I hope that you see right away, without even counting, that these carbons don't have an octet. So what I'm going to do is form a double bond. And so as you see, I have 4 hydrogen-carbon bonds and 1 carbon-carbon double bond. My next compound is going to have a single bond. And then over here I have my 2 carbons. And since I've added the hydrogen bromide to my bromine, I am now going to have a hydrogen and a bromine that break that double bond. And so now I have just a single bond between my carbons. So if I look at the bonds here, I have 1 carbon-carbon bond, I have 5 carbon-hydrogen bonds, and 1 carbon-bromine bond. So now I'm going to look up in page 11 and figure out what the enthalpies are of all these particular bonds. I'm going to add all the bonds broken in my reactants, and I'm going to add all the bonds formed in my products, and then I'll end up with an enthalpy. So if I look up the carbon-carbon bond, I find that it has an enthalpy of 614. The carbon-hydrogen bond has an enthalpy of 414 kilojoules per mole, and there's 4 of them, so I multiply that times 4. I have one hydrogen-bromine bond, so that's an enthalpy of 366. Now I add those all up, and I'm going to subtract from that the carbon-carbon bond, which is an enthalpy of 346, 5 carbon-hydrogen bonds with an enthalpy of 414, and 1 carbon-bromine bond with an enthalpy of 285. So when I add both of those up and then subtract, I find that the enthalpy of reaction the enthalpy for this particular reaction is a negative 65 kilojoules per mole. Now, a typical IB problem won't stop there. They'll have you then calculate the enthalpy of reaction for the same reaction using either an enthalpy an energy cycle diagram or Hess's law, and then to compare the two enthalpies and discuss why they're different. And that's when we go back to our definition of bond enthalpies and the assumptions that we make with those bond enthalpy calculations.